Hello, lovelies. In this video, we are going to learn about balanced and unbalanced forces. Let's begin. So you've heard your entire school career that a force is a push or a pull, and that hasn't changed. It's still what a force is classified as. But what we're adding in is how we diagram forces and different kinds of forces, or different categories of forces. So to start with, we use arrows to show the forces acting on an object. So on this car, I see 7 forces. I see air resistance, I see friction, contact force, the weight of the car is a force acting downward. And each of those arrows show the direction that each of those forces applied in. So like for example, air resistance is being applied this way to the right. So there's 2 categories of forces. Forces are either balanced or unbalanced. And depending on what the force is, it affects the motion of the object in different ways. Balanced forces is one category of forces. Forces are balanced when they are equal and opposite in acting on an object. So equal means equal in size, and opposite means opposite in direction. So balanced forces affect motion in 2 ways. When forces are balanced, either the object stays still, like this car right here, or the object continues to move, however it was moving, at a constant speed and in the same direction. So in this instance, there's 2 forces being applied to the car here, but they're equal in size. So this guy is pushing on the car with the same amount of force as this guy over here, but they're in opposite directions. And because one isn't bigger than the other, the object doesn't change its motion. It stays still. In this example, the biker has equal forces acting on her, where these 2 forces are the same size, even though there's 2 arrows here, which means 2 forces, and 1 arrow here, these forces are equal to this 1 force. It's just that they're opposite in direction. So because they're equal in size and opposite in direction, it's not going to change her motion. She's going to stay at a constant speed, going in the same direction. Balanced forces result in no change in direction or motion. So like I said, if it's still, if it's not moving, it's going to stay not moving. If it's going at a constant speed, it's going to stay at a constant speed, going in the same direction. Unbalanced forces are a different category. Forces are unbalanced when forces acting on an object are not equal or balanced. So let's look at what that means. There's lots of different examples for unbalanced forces because typically forces are unbalanced. Unbalanced forces can cause a moving object to speed up or slow down. Object that's still causes it to start moving. A moving object to stop moving, or a moving object to change direction. So far, we've learned this as acceleration. So unbalanced forces cause acceleration. Here are some examples of unbalanced forces in your everyday life. So friction is a huge unbalanced force. You experience friction all the time. Friction resists the motion of an object. Whatever the motion is, friction goes against it. So imagine an arrow going in the opposite direction of whatever direction you're going in. It always acts in the opposite direction of another object's movement. Smooth surfaces and objects that have less friction or smooth surfaces and objects have less friction than textured surfaces. So like a slide or something like that. The smoother it is, the less friction it is, or there is. Another example of an unbalanced force that acts on you constantly is gravity. Gravity is an unbalanced force that pulls downward and causes an object to change its motion. I mean, think about it. If you try to hold a book or a pencil or whatever you have around you above your head, and drop it, gravity is the unbalanced force that causes the change in the motion of the object. Air resistance is another unbalanced force. You probably don't think about it, especially if it's not very windy, but air resistance is the force applied by air molecules to an object in motion. So just like friction, it goes against motion. It opposes motion. This is why it's difficult to walk or run in the wind on a windy day. This is the exact same reason why football teams like to kick off in the same direction that the wind is blowing, because the air molecules offer a force. They apply a force. So let's look at some more examples. Let's look at this cat right here, just sitting. Are the forces acting on the cat balanced or unbalanced? The forces acting on the cat are balanced. The cat does not move, so it doesn't change its motion. Therefore, the forces are balanced. The forces acting on the player here, are they balanced or unbalanced? They are unbalanced because the player starts moving, speeds up, and then stops moving. And then finally, are the forces acting on Sugar Mama's car balanced or unbalanced if she's driving at a constant speed? Well, if it remains constant, that means there's no change in motion, which means the forces are balanced. That's about all that we are going to talk about in this video. Remember, balanced forces cause no change in motion. Unbalanced forces do cause change in motion, and arrows are used to represent directions of forces. If you have any questions, ask your teacher before moving on to the next step.